Hi guys, in this video we are going to see how to calculate the power loss for the diode, okay, and why we have to calculate the power loss in a circuit for the diode used in the diode, okay. And in power loss perspective, what is the difference between the general purpose diode to with the Schottky diode, okay. This is the agenda for this video, and if you like this video, click the like button. Let's get into the topic, guys, okay. So before that, let us see how the diode operates. Okay, just a quick recap. We can do it. So diode is a one-way switch. That means you can see that this is a anode terminal and this is a cathode terminal, right? When anode is positive with respect to cathode, it is called a forward biased. And at that time, it's called a closed switch. Okay, it allows the current to flow from the anode to cathode. Okay, and when the anode terminal is negative with respect to positive, that means it is when it is in a lower potential than the cathode terminal, then it's called reverse biased and it's called completely open switch. Okay, and in below I am showing here the ideal characteristic as well as the real-time characteristic, practical characteristics. Okay, in ideally, if you see the ideal diode, when it is forward biased, there is no voltage drop across the diode and it's completely connecting the current. Okay, there is no loss at all, but whereas in real time there is some loss will happen. Okay, and you are seeing it's at zero itself starting completely here, whereas here after some time only it's starting here, and it's not the straight line, it is a slope here, right? This is the thing we have to consider when calculating for the power loss. Okay, and when it is starting, you are seeing it here, that 0.7 volt for silicon diodes. If the diode is made up of silicon material, okay, and it's a general purpose diode, usually we say 0.7 volt, and that's called a threshold voltage. Okay, and if it is a Schottky diode, it will start from the 0.2 or 0.3. That's what you will get in various textbooks. All the textbooks you will get it here. Okay, let us go into some data sheets and check it out also real time. We'll walk through some data sheets. I open some of the from Vishay. Vishay is one of the manufacturer, and diodes incorporated. Some of the diodes, let me open it. And from the Farnell distributor on semiconductor. Okay, it's a rectifier grade diode. Okay, and here in this rating, I'm just going to the maximum data ratings. Okay, here if you see it, yeah, moreover here the power loss in the diode is power is nothing but V into I is the power, right? The same way the power loss formula for the diode is forward voltage drop multiplied with the actual forward current going through the in the circuit. Okay, this is one of the circuit example circuit I had given here. If you see it, that forward current, how much forward current we have to calculate it, we can let us calculate. It's a 6 volt battery from the 200. So it is 30 milliamps current. It's right now it's in this example it's 30 milliamps current. Okay, and we have to go to the data sheet, and corresponding to 30 milliamps, what is the voltage drop, that we can say it, or approximately if you want to take it up, you can take the 0.7 into 30 milliamps. That is the power loss, actual power loss occurring in this diode for this circuit. Okay, so let us go through this some of the datasheet. This is from the Vishay, and they are saying, see, forward voltage drop is 1.1 volt, but let us see at what condition they are doing it 1.1 volt. Okay, see here it's a maximum average forward rectified current is 1 amps. Here forward current is 1 amps. Average forward current, they are saying, we are talking about the forward voltage drop VF. We have to see it, that is the maximum ratings, how much it is, how much maximum it can handle it. Maximum reverse voltage up to this part number is 50 volt it can handle, and this part number it can handle up to 1000 volt also. Reverse voltage application means when bias in reverse biased condition. Okay, it can even handle 1000 volt also. If we apply in across this diode in other manner, that means 1000 volt also, if you flip it this diode, and apply across 1000 volt also, that particular part number will withstand. That is the meaning of that one. Okay, so we'll see. Yeah, VF here is the right. Instantaneous forward voltage drop is 1.1 volt, but test condition is 1 amps. When 1 amps is flowing through the diode, the drop will be 1.1 volt. Okay, for all the part numbers. That's what here it is saying there. Whereas this another part number, see here it's saying that not recommended for new design. These kind of things will not use it for our upcoming projects. That's the meaning for this one. And here forward voltage at 1 amps rating they are saying is 1 volt only. See, compared to the previous 1.1 volt, here is 1 volt only, right? But theoretically what we are seeing is 0.7 volt they are talking, right? But in actual manufacturer to manufacturer, it is a little bit different here. And here this one we are taking on semiconductor. From on semiconductor, the forward voltage drop is, yeah, typically 0.93 also. 1 amps it is saying that 0.93 also typically will be there. Okay, and here one more, every curve it will show some curve will be some graph they'll share it. One is the VA characteristics, VF versus IF, right? So this is nothing but in data sheets, it's nothing but this one, this quadrant only they have taken it, right? So voltage versus current they had given here, VF and IF. Here they are saying it at 150 degrees Celsius at higher temperature, it starts at earlier voltage drop. So the drop will be very less across the diode. That is the meaning here. That means here at 0.6 itself it's starting. At room temperature 25 degrees Celsius, it's not 0.7, 0.8, and 1 amps it is 0.95 or something it's consuming here. Okay, if your circuit, your actual circuit, what is the forward current is taking, that's the thing first you calculate it. Okay, and then go to the data sheet of your selected diode. There you go through in the characteristics, electrical characteristics. There you see what is the voltage drop. Okay, VF typical value you see it, that you can take it up. Even if you want more accurate value, go to the graph and see what is the VF corresponding to your applied current. Okay, that is the power loss. Okay, now our next question, why we have to calculate the power loss? Why we have to calculate power loss? We saw some few examples. We saw what is the diode operation quickly, and how the power loss calculation is VF into IF. Okay, and IF is your actual current in your circuit, and VF is the forward voltage drop. Okay, generally we can say 0.7, or exactly you can see the graph and you can see it. And why we have to calculate the power loss? Come to the next question. See, once you done the power loss, some value identify it, and every device has some ratings. They'll say maximum power dissipation, maximum power rating they might have given. This is the maximum ratings they had given, right? So if you see the wattage, if you see it, maximum power ratings they'll give it. Okay, in this manufacturer they have not given, but it will be there somewhere. For quick purpose, let us see it other things also. So this power loss should not burn your device. That's the only thing. Okay, if you apply more current also, it may burn. Okay, beyond, say for example, if the current flow via the diode is more than 1 amps also, the diode will get damaged, right? The same manner, if the voltage apply also, too much of voltage applying occurs beyond this maximum rating, then also the diode will it will burn, right? So we should not damage the device. That is the reason we are giving the power loss, we are calculating it. Okay, and it has to be within the reasonable limits, that as per the here in this case VF versus IF they have given here. It starts from the 0.7 and it's for corresponding 1 amps or corresponding to 10 amps. So what is the rating? It is there, how much drop it will take. So that value we have to take exact power loss value, and that we have to replace into your circuit, actual circuit, and overall circuit, how much power it will dissipate, that you have to calculate it. So that is the reason we have to do it for the power loss, calculating the power loss. Okay, and what is the difference between the general purpose diode as well as Schottky diode in power loss perspective? Let us go through it. Let us search Schottky diode, some of the Schottky diode data sheets, and compare with the general purpose diode. See, as I previously mentioned, the threshold voltage for general purpose diode or PN junction diode is zero point 0.7, whereas here it will be 0.2 or 0.3. That's what you might have studied in your textbooks, right? And if you go through it here, Vf value to see here, forward voltage at 1 amps is 0.4 to 0.6 only. Okay, this is from the diodes incorporated devices. You're saying that 1 amp Schottky barrier rectifier. Okay, the same thing we opened previously also here. This is 1 amp rectifier. Okay, the same manufacturer same only, but this is the PN junction diode, general purpose diode, right? And it's also 1 amp rating diode. And whereas here it is saying that 1 amps, the voltage drop will be 1 volt, right? Whereas here, this guy in Schottky barrier diode, it is, for this part number is 0.45 only, just half of that value only, right? So then if you place this value, if you place this value into your formula Vf and If, then obviously the power loss will be very less, right? So compared to general purpose diode, the Schottky barrier diode will consume very less power. It will dissipate very less power. So that is one of the advantage compared to the PN junction diode for this Schottky diode. Okay, but then we can say why we can always use this Schottky diode, right? Why we have to go with the PN junction diode? The reason is, see here in this example, the reverse voltage, maximum reverse ratings is saying that DC blocking voltage is 20 volt only. It can withstand up to 20 volt only or 40 volt only. That means if you apply the voltage more than 20 volt in a reverse manner, if you flip this in that reverse biased condition, if you apply more than 20 volt or more than 30 volt in this case, right, then the device will go bad by mistake, or any surge happened also, it will go bad. Whereas here the same company with their series, what is the rating they are saying? See, it is 50 to 1000 also they are saying it. There is DC blocking voltage and all. That means if we can withstand up to 1000 volt also. So that's the reason in circuits they are using general purpose diode as well as the Schottky diodes. Yeah, these are the things. We pretty much cover all the points agenda. I believe that. Yeah, guys, if you like this video, please click the like button. Take care, guys. Bye now.